All right. Dividing radicals. So this is a lot like multiplying. The numbers in the front, you divide those. And then the numbers under the radical, you can divide those numbers as long as it's the same index. So if I have two roots being divided, this is the same thing as that same root, a divided by b. So they would both have to be the square root or the cube root or the fourth root, but then you just divide the numbers in front of or underneath them. And then you divide the coefficients in front like you would normally divide. So on number 1, we've got 12 divided by 2, which is 6, and then it's going to be the square root of 160 divided by 5, which is 32. Can the square root of 32 be broken down anymore? What perfect square goes into 32? 16. So 16 times 2 is 32, right? And what is the square root of 16? 4. So this is really 6 times 4, square root of 2. And what is 6 times 4? So 24 square root of 2. What is number 2? 36 divided by 9. 4. And then we have the fourth root. What is 1250 divided by 2? 625. Anything special about 625? It's a perfect what? Fourth. It would need to be, because this is the fourth root, so it is a perfect fourth. If it's already perfect, do we need to split it up? No. What is the fourth root of 625? 5. And 4 times 5 is 20. Number 3. 28 divided by 4 is 7. And then we have the cube root. Negative 16, x to the 6th divided by 2x is negative 8, because that negative, x to the 5th, because you have 6 on top and 1 on bottom. And think about if you were to cancel off one of the x's, you're left with x to the 5th there at the top. Good job. Now, are both of these perfect cubes? No. Everything in there is not a perfect cube, so we have to split it up. Is the negative 8 perfect? Yes. And remember, when you're doing cube, you put the negative on the perfect side. The x to the 5th is not. How many x's do I need to move out to make it a perfect cube? It needs to be a multiple of 3. So you need to take out 2 of them. Then we have x to the 3rd power. If we only take out 1, it's x to the 4th power, which is not a multiple of 3. Cube root's got to be multiples of 3. What is the cube root of negative 8? Negative 2. Cube root of x cubed? X. And then we're left with the cube root of x squared. And what is 7 times negative 2? Negative 14 x cube root of x squared. Number 4, the entire thing is in a fraction, but that's the same thing as having the 4th root of 32x over the 4th root of 81. Now, can you do 32 divided by 81? No. So it would actually be easier for us to simplify the top and simplify the bottom. So how can we break up the 4th root of 32x? So the 4th, remember we're looking at 4th roots. 16 is the only perfect 4th that goes into 32. 16 and 2. Now this x, is it perfect? Nope, so the whole thing goes over there. 4th root of 81. 81 is a perfect 4th, so it is 3. What is the perfect, or the 4th root of 16? 2. So this would be 2, 4th root of 2x over 3. And that doesn't simplify. 2 over 3 doesn't simplify down at all. Okay. So all of these that we've done, if we had a denominator, there's been a whole number in the denominator. Sometimes you'll be left with a square root in the denominator, and for whatever reason, somebody decided they didn't like that. I don't have a good explanation as to why, but you can't leave a square root or any kind of root in the denominator. So you do a process that is called rationalizing the denominator, getting a whole number in the denominator. And so it depends on what's in your denominator. So look right here, if you have a monomial, so just like these 4, nothing is being added or subtracted in the bottom, you're going to multiply the numerator and denominator by that radical. So if you multiply a fraction by something, if you multiply by the same number on the top and the bottom, it doesn't actually change the fraction. It's like you're multiplying by 1. So that's what we're going to do. So like on number 5, we will multiply the top and the bottom by square root of 5. And you'll see that we'll get rid of the square roots in the bottom. Now on the back side, we're going to do some that have binomial denominators. And that's a little bit different. So let's go ahead and do these 4. So I want to get rid of the square root of 5. So I'm going to multiply the top and the bottom by square root of 5. That's essentially multiplying by 1. So what is 3 times the square root of 5? One's outside, one's inside. You can't do anything with those numbers. So it's really 3 square root of 5. What is the square root of 5 times the square root of 5? The square root of 25. They're both under the square root, so you can multiply those. Well, what is the square root of 25? 5. So this is 3 square root of 5 over 5. And if you type both of those into your calculator, 3 over square root of 5, you should get the same decimal. 3, whoops. So they're the same, just look a little different. Number 6, we got to multiply the top and the bottom by what? Square root of 15. What is the square root of 8 times the square root of 15? Square root of 120. And the square root of 15 times the square root of 15 is the square root of 225. 120 is not a perfect square. So how can I break it up? What's the largest perfect square that goes into 120? Anybody? Has anybody found one? 4 and 30. And what is a square root of 225? 15. What's the square root of 4? 2. Square root of 30 over 15. Does 2 over 15 simplify at all? No. Number 7, we have 4 square root of 7 in the bottom. You only have to multiply by the square root of 7 for it to work out. So if I multiply the top and the bottom by the square root of 7, we would get 3 square root of 84 over 4 square root of 49. 84 is not a perfect square. What is the largest perfect square that goes into 84? It is 4 and 21. What is the square root of 49? 7. So what's the square root of 4? 2. So 3 times 2 is 6. We've got 6 square root of 21 over 28. Does the 6 and 28 simplify? They're both multiples of 2. So you don't worry about what's under the square root, just the numbers in front. So this would be 3 square root of 21 over 14. Try number 8 on your own. So you had to multiply the top and the bottom by square root of 3, giving you 2 square root of 84 over 5 square root of 9. And so this 84, we just did that one in number 7. So you should have known it was 4 and 21. And you get 4 square root of 21 over 15. Let's turn over. And here on the back, we have binomial denominators. So the bottom, there's 2 things being added or subtracted, and one of those has a square root. It would not work for me to just multiply by the square root of 2. We multiply by what is called the conjugate. So conjugates, that's a fancy word. And if I'll use number 9, 4 plus square root of 2. The conjugate has the same numbers, but one of them is a minus. 4 minus square root of 2. it works out a lot like difference of squares. It's kind of the same concept. This will help eliminate the square roots, doing it this way. So we're going to multiply the top and the bottom on number 9 by 4 minus the square root of 2. In the bottom, what do I need to do to multiply those? Box method or FOIL, whichever one you prefer. So if I go here to the side, I'm going to go ahead and do that. Four, and then a positive square root of 2, 4, and a negative square root of 2. And this is specifically for the denominator. What is 4 times 4? 16. 4 times negative square root of 2? 4 times square root of 2? 4 square root of 2. And then negative square root of 2 times positive square root of 2. Negative square root of 4, which is negative 2. Every time you do this, when you multiply by the conjugate, you're always going to get these two to cancel out. So notice you had a negative 4 square root of 2 and a positive 4. Those made 0. And so if I go back to my fraction, this denominator was, when I multiply those, I get 16. Then I had that minus 2 on the bottom. On the top, the numerator, we have to distribute. What's 4 times 4? And then 4 times negative square root of 2. Yeah, negative 4 square root of 2. So this is 16 minus 4 square root of 2 over 14. And then you have to look at these three numbers to see if they're all divisible by anything. Can you divide any of the, or all three of those numbers by something? Divide them all by 2. So this would be 8 minus 2 radical 2 over 7. Number 10. What do I need to multiply the numerator and denominator by? 6 plus the square root of 5. So I'm going to go ahead and do that bottom. Six times 6 is 36. We would get 6 square root of 5 and negative 6 square root of 5, which we know are already going to cancel out. And then what is in this bottom right box? Yeah, I'm going to go ahead and put negative square root of 25, which is negative 5. So if you can remember on these that those middle terms will always cancel out, you can probably get this without actually writing out the box. But, you know, you're kind of iffy on it, go ahead and write it out, because otherwise, when you go to do other problems that don't have the ones that cancel, you might just get in the habit of only multiplying the first and only multiplying the last. So use your own judgment on that. Okay. So on the top, the numerator, we're going to have 2 times 6 is 12. And then when I multiply the 2 and the square root of 5, it's plus 2 square root of 5. And then on the bottom, I've got 36 minus 5, which is 31. Can you divide 12, 2, and 31 by something? No. All right. Number 11. What do we multiply the top and the bottom by? Yep. What's 1 times 1? 1. And 1 times negative 4 square root of 2 is negative 4 square root of 2. And 1 times positive 4 square root of 2 is positive 4 square root of 2. What is 4 square root of 2 times negative 4 square root of 2? Negative 16 square root of 4, which is negative 32. These cancel. All right. On the numerator, when I distribute, 2 times 1 is 2. 2 times negative 4 square root of 2 is... No, remember, you only multiply the numbers in front. So you can only multiply that 2 because it's not under a square root. You can only multiply it by a number not under the square root. Okay. On the bottom, I've got 1 and negative 32, which is negative 31. If you'll remember back to maybe a part in Unit 5, I'm not exactly sure, but if you remember back, we try to avoid leaving negatives in the denominator. So it's really easy to change those. If I want to make this a plus, I make this a minus and this a plus. So you can change all of the signs. And this would be negative 2 plus 8 square root of 2 over 31. One more question. Try number 12 on your own. You should have multiplied by 2 plus 3 square root of 5. And so I went ahead and did the bottom, the denominator. So the only terms that I'll end up having are 4 and negative 45. Denominator, when we multiply, we get 2 square root of 3 and 3 square root of 15. Remember, you can only multiply numbers under the radical by each other and only multiply numbers in front of the radical by each other. And then we have the negative 41 on bottom, but I need to change my signs to end up, because I want a positive number on the denominator. That would make that a negative, and a positive. Are there any questions?